Okay, this video is, well, it's talking about the leading coefficient test, right? So we're going to get to what that leading coefficient test is, but basically we're trying to decide whether our graph is a positive graph or a negative graph. Okay, is our graph positive or is our graph negative? Because all positive graphs basically look the same, and all negative graphs basically look the same. Okay, so we're just going to decide, is our first term positive or is our first term negative? And then what is the power, right? So if you have an even polynomial, as in it has an even power, 2, 4, 6, 8, 10, then your graph is going to look like these two green ones, right? Positive ones have positive infinity as their end behaviors, right? Both of their ends go up. And negative even graphs have negative infinity as their end behaviors. Okay, we're going to talk about rising or falling. And then if we have a positive odd function, okay, a positive odd, then the end behaviors are the same as the x's. So as x goes to negative infinity, the graph will fall. And then if it goes to positive infinity, the graph will rise. Okay, so it grows from left to right. Okay, low on the left, high on the right. And then if it's a negative odd, then they switch, right? So we have infinity in the second quadrant, and we have negative infinity in the first quadrant. Okay, so that's basically where we're going when we're going to fill out this next table here, which are part of your notes. Remember, that was a poster that's on my wall. So here are your notes. Okay, so we're looking at, first of all, do we have an odd or an even degree? Right, we're just looking at the power of your problem, just the power. And then the second one, is it positive or negative? Is this first term a positive or negative? And then these are the questions about the end behavior, right? As x goes to negative infinity, what is the y value doing? And as x goes to positive infinity, what are the y value? Are the y values rising or the y values falling? Okay, so we'll do a couple of these, and then I'm going to pause the video, and we're going to do all of them in class. And then the answers will magically appear on the page. So number one, is number one an even or an odd degree, right? An even degree because there is a 2 as the highest power. Okay, is the leading coefficient positive or negative? Positive, right? And you can just put a plus in there if you want to as a positive. So thinking about the graph, what's going to happen on the left side of the graph if we have a positive even? Okay, positive even on the left side of the graph is going to go up, right? He's using the words rise, go up, so rise or fall. So his word is rise, but basically it's going to positive infinity, right? So that's where the y values are going. As x goes to negative infinity to the left, the y values are going up, right, to positive infinity. And then the same thing for your the left side. This is the beautiful thing about a positive even polynomial, is that if it's even and positive, then both of your ends go to the same place. Okay, they both go up if it's positive. And if it's negative, then they both go down. Okay, so this is what I'm trying to get you to understand, is that for even polynomials, the end behaviors are the same, and for odd polynomials, right, they're different, okay, because of the way that they're graphed. Okay, number two, is this even or odd? Even, right, so it has an x to the fourth. This is an even polynomial. The leading coefficient is negative, so you can put a minus in there. Right, so now we're looking at a negative odd, a negative even polynomial. So our ends are going to fall on both sides. Right, they're both going down to negative infinity. Just because it's a negative even polynomial. Okay, and all negative even polynomials behave like this. So we are making generalities or general statements based upon whether it's positive or negative and even or odd. Okay, so that's what I want us to do on this whole entire worksheet, is decide what's going on with these polynomials. Okay, so I'm going to pause it right now, and you should pause it too and find all the answers. So there is the rest of the table. Okay, making all these, noticing, of course, hopefully you're noticing that evens, and if they're positives, then they go up on both sides and whatnot. So we're going to make a chart for that here on the back side of our notes that puts all that information. Basically, everything on the poster, right, everything on this poster is going to now be in a table in your notes. So here's the table from your notes. Okay, so we have degrees. The degree is either even, or odd and odd. Okay, so we either have an even function or we have an even polynomial or an odd polynomial. Okay, and then it's either positive or it's negative. Okay, so we have even positives and we have odd negatives. We have even negatives and odd positives. So all of these behave the same. To the left, the graph will rise if it's even, and to the right, the graph will rise. Okay? So we're going to write, not rise, right? We're going to use more mathematical notation. So this is as x approaches negative infinity. We're going to write the y values approach positive infinity. So it goes up, right? And the end behavior, as x goes to positive infinity, the right side of the graph, our y values also go up. Okay, so we're going to write it with more mathematical notation rather than just rise or fall. Okay, but rise means it's going up to positive infinity, and fall means it's going down to negative infinity, right? So if it's even and negative, the graphs are opening down. Both ends go to the same place. Okay? So always, with even functions, your left and your right end behavior are always the same. Okay, they either both go up to infinity, they both rise, or they both fall to negative infinity, if it's a negative. Okay? Now your odd functions always behave the same as the x value. So if x is going to positive, or rather negative infinity, then your y's also go to negative infinity. Okay? And on the right, if your x's go to positive infinity, then the y's also go to positive infinity. Okay? For a positive odd, the y values behave the same as the x values. But for a negative odd, the y values behave the opposite. So as x goes to negative, y goes to positive. And vice versa, if x goes to positive, y goes to negative. Okay, so remember, negative means fall and positive means rise, as far as what we were doing a second ago. So here is where it's going to be handy, is to be able to write an equation. Okay, so we want to do this, determine the leading coefficient of your equation. Okay, so let's look at our first example here. Here is your graph. The zeros, where do we find the zeros? So we have one crossing here at x equals minus 3, and we have another crossing at x equals negative 1. So those are the two places where the graph crosses your x-axis, so those are your zeros. Now each zero has a multiplicity. So the multiplicity at negative 3 is going to be 3, because our graph flattens as it crosses. Okay? Yes, that should be positive 1. Excellently well cited. Good job. Positive 1 it crosses. Very good. That's why I have smart students. At negative 3, the graph flattens, and when it flattens, that means we automatically have a multiplicity of 3. Okay, m is not slope. Maybe I shouldn't write m equals. Maybe I should do m colon or something, because it's not, as multiplicity is 3. And our multiplicity at positive 1, where the graph crosses the x-axis normally, it has a multiplicity of 1. So of course, we talked about this yesterday, but then what is the degree of our function? If we have a multiplicity of 3 and a multiplicity of 1, 3 plus 1 equals a 4th degree polynomial. Okay, yes, this is called a quartic, but I'd much rather you just know that it's a 4th degree polynomial. okay, which is, of course, an even polynomial. Okay, so notice that both of the arrows are pointing down in our even polynomial, right? They're both going down to negative infinity. So that means that the leading coefficient is going to be negative. Okay, we're going to have a negative leading coefficient, so we put a negative on the outside there. Okay, so then our factors, right? We're going to write this in factored form. If I have an x minus 3 solution, that means I have an x plus 3 factor. And because I have a multiplicity of 3, this factor is going to have a power of 3, right? All of these things are tied together. They're helping us write the equation. And if I have an x value of 1, that means I have a factor of minus 1. Okay, and because I have a multiplicity of 1, I don't have to write a 1 up there. Everybody understands that that is going to be a 1. Okay, so this is a possible equation as factored, right? These are the factors. So this is what we're looking for right here. Okay, unless they ask you to multiply it all out in standard form, that is sufficient for your equation. Okay, then write a possible equation. There we go. All right, the second one here. What are the zeros? Where does this one cross the x-axis? Let's see if I can get it right. One of them is at -2, and the other one is +1. Okay, so those are your two zeros. That's where it crosses or touches your x-axis. Now, what about the multiplicity? Because the graph crosses, right, that's a crossing normally. This has a multiplicity of 1. And where x equals 1, what is the graph doing at the x-axis? It is bouncing. And a bounce means we have a multiplicity of 2. So if I have a multiplicity of 1 and a multiplicity of 2, that means this is a third degree polynomial, because 2 plus 1 equals 3. The degree of your polynomial is always the sum of your multiplicities, which means this is an odd polynomial, right? 3 is an odd number, so this is an odd polynomial. Now let's look at the ends. So as x goes to negative infinity, the y's are rising. And as x goes to positive infinity, the y's are falling. So what is the sign of this odd function? This is a negative odd function, right? This is exactly what a negative odd function looks like. The x and the y's are opposite. So when we come over here to write our equation, right, we're going to put a negative in front because we have a negative polynomial. And then x plus 2 is the factor for x equals -2, and then x minus 1 to the second power, since we have a multiplicity of 2, is going to be your factored form for an x value of +1. Okay, so this is what we want to be able to do, is look at a graph and write an equation for it. And it says a possible equation because we don't know what the y-intercept is, so we don't know if there's a 2 in front of your x cubed or a 3, right? We don't know how much it's been stretched. Okay? So our next little section is about a table. So here's our table. We're told that this is some random polynomial function. The zeros in the table are the only zeros of the function, and no zeros have a multiplicity greater than 2. Okay, so that's going to help us when we write our equation. So what about the left and the right end behavior of the function? Okay, so at -6, look at this y value. What do you think the y values are you doing as x goes to negative infinity? Are the y values getting smaller or the y values getting bigger? They're getting bigger, right? 360 is way bigger than 3.46437. Okay, so that's on the left side. And what about the right side? As x goes to positive infinity, we have the number 490. So that means the y values are also going up. Okay? So we have a function where the left side and the right side are both rising. Okay, so based on end behavior, what is true about the degree of the function? It's an even function. Okay, we can definitely say that it's even. Is it a fourth root? Is it a sixth power? Is it an eighth power? Right, that we don't know, but we know that it's even. And the fact that these both go up to positive infinity means that it's also positive. Okay, this is a positive even polynomial. Okay, and all the things I just said are your reasons, right? Both of your n values go up, n behaviors rise. Okay, which means it's both positive and even because your n behaviors rise on the left and on the right. Okay, so both of them are the same. N behaviors, right? Pure plural. Okay, identify the zeros and the multiplicities. Okay, so we're looking for y values of 0. So here we have a y of 0, here we have a y of 0, and here we have a y of 0. So we have 3, 1 at -3, another 0 at -1, and our third 0 at +2. Now, what can we say about the multiplicities? So let's look at these y values that are around -3. Okay, so here we have -3 as the x value. On the left at -3.5, we have a y value that's positive. Right? And on the right side at -2.5, we have a y value that's positive. Okay, and since we have a positive on the left and a positive on the right, that must mean that our graph would have bounced there, right? If we have a positive on one side and a positive on the other, but there's a 0 in the middle, that means the graph bounced at -3. And if the graph bounces, what can we say about the multiplicity?
2.
It has a multiplicity of 2. So the -3, 0 has a multiplicity of 2. Okay, let's move over and look at -1 and do that same type of a sign analysis. At -1, the left side is positive, right? There's a positive on the left side. 3.999 is positive. And on the right side, the graph is negative, which means that the graph has to cross. So at -1, the graph will cross. And since it says we don't have a multiplicity greater than 2, that means this has to have a multiplicity of 1, right? Because it could be a 3, but we can't tell that it flattens, and it can't be higher than, oh, I just said it can't be higher than 2, but then I wrote a 3. This has to have a multiplicity of 1. And then our last 0 at +2, what is going on? We have a negative on the left and a positive on the right. So it's going to cross at +2 also. Right? Negative on one side and positive on the other means that the graph crosses your x-axis. Okay? So those are your zeros and the multiplicities, right? Based upon the signs, the sign on the left side and the sign on the right side. If the signs are the same on the left and the right, that means your graph has to bounce. And if they're opposite on the left and the right, that means your graph has to cross. Okay? So we have 2 more problems that I think we're just going to do here in class, and I'll put the answers on here in a minute. Okay, so here are the last 2 problems, right? Fully graphed. We have a negative odd polynomial. So it's going to end up looking like this, right? It starts in the second quadrant and ends in the fourth quadrant, because that's how all negative odd polynomials do. And this one is a positive odd polynomial. So it starts in the third quadrant, and it grows and it ends in the first quadrant, like all positive odd polynomials do. Okay, so this whole lesson is so that you can be able to make sense of how the graph looks based upon your zeros and their multiplicities. Okay, and we're done.